Okay, I'm doing the key to the whiteboard practice. I'm doing a video on it to help you with your final exam. So please, I hope that you are viewing this video and that it helps you prepare for the final. Okay, to determine whether or not a sequence is arithmetic or not, it has to add the same number to every term throughout. You don't just look for a pattern, you look for the same number to be added. So this one's going plus 4, plus 4, plus 4. So yes, it's arithmetic. This one's going plus 2, plus 2, plus 2, all the way to the end. Same thing here, plus 2, all the way to the end. This one is going times 2, so it's not. Determine whether it's linear or not. Now you can use Desmos and you can put all of these into Desmos and look at the graph. If it forms a line, then it's linear. If it doesn't, it's not. However, looking at the equation, if the variables do not have an exponent, then it's linear. Or if, like here, this number, my variable is my exponent, then it's not linear. So you don't want your variable to have an exponent. So y does not have an exponent. This is a horizontal line simply because there's no x. So yes, then this is a quadratic function because it's x to the second power. This is an exponential function, which we'll get to more in January, but you see x as an exponent. And here, x does not have an exponent. It's linear. All right, this graph, you can graph it one of two ways. You can do it by hand the way that I taught you to do, which is to start at 4 on the y-axis right here and then count your slope and go down 3 to the right 1 and sketch it. Or you can put it in Desmos, see what Desmos says, and sketch it from there. The slope and the y-intercept's where the graph crosses the y-axis, is crossing right here at the point 0, 2. And then the slope, you just count it. This one's going up, so you know it's going to be positive, and it's rise over run. So I'm going from here to there. I went up 2 to the right 1. So it's got a slope of 2 over 1 or just 2. Given this arithmetic sequence, find A1. A1 means what is the first term? It's 20. A5 means what's the fifth term? Well, you've got 4 and you're going minus 3, so take 11 minus 3, that gives you 8. Now, to use the formula that the state is going to give you for explicit formula, that's what this is. Remember, A1 is the first term, so I put 20 in. And then my common difference, I'm subtracting 3, so I made it minus 3. And then I put n minus 1 in the parentheses. I distribute that. I just distribute that within the parentheses. That gives me negative 3n plus 3. And then I add like terms. I've got like terms right here. 20 plus 3 is 23 minus 3n, or they may put the 3 in first and have negative 3n plus 23. Now the other way to do it, and the state doesn't teach it this way because in all honesty there really isn't a 0 term, but if you're adding 3 this way, then you're subtracting 3 this way. So, I'm sorry, if you're subtracting 3 this way, then you're adding 3 this way. So that 0 term would be 23. And you see this right here? And then we're subtracting 3, so negative 3n plus 23. Either method works. All right, domain. Remember how I taught you to label your axes. This is forever infinity that way, forever negative infinity that way, forever infinity that way, forever negative infinity that way. Remember, I taught you that an arrow has an x and y coordinate just like any point on the line does. So this arrow falls between this x and this y, so its coordinates are infinity and negative. Infinity and infinity, sorry, getting tongue-tied. This one here has an arrow right here that falls between these. This is its x, this is its y. So when you're looking at the domain, you just look at your smallest x value to your largest x value. So negative infinity to infinity. And again, for range, you look at your smallest y value to your largest y value. So negative infinity to infinity. X-intercept, this is crossing at negative 1, 0. Y-intercept is crossing at 0, 2. And my slope, again, it's rise over run, up 2 to the right 1, so it's got a slope of 2 over 1. Positive. Remember, I taught you to draw a solid line on the x-axis. So when it says positive, what it really is talking about is where is y positive. Y is positive up here, y is negative down here. And it wants you to label what the x-coordinate is. So the x-coordinates where y is positive are -1 to infinity. The x-coordinates where y is negative are -infinity to -1. End behavior. Literally read your arrows. That's why it's important to be able to label. So as x approaches infinity, f of x or y approaches infinity. As x approaches -infinity, f of x approaches -infinity. Plug it in and evaluate. So you want to put 2 in for x. So 7 times 2 is 14. Minus 4 is 10. All right. Remember, your initial that's your starting point. That's always the part of the equation without the variable. When it says the word each or per, that's the part that gets the x. So my equation is y equals 100x plus 40. Then think about that. As your hours increase, the photographer's total profit increases. As the hours they're working decreases, then the profit decreases. And to put that in a mathematical end behavior thing, increase means infinity, decrease means -infinity. And that's why we wrote what we did here. All right. If you look at this on Desmos, then you can look and see which one of these work. 0, 0 works, -1, 3 works, and 5, these two do not. So you just look in Desmos or plot it, or you can you can do this. You can plug 0, 0 in. Y is 0 is greater than 3 times 0 minus 4. 0 is greater than -4. That's a true statement. You can plug this one in. Just be sure you plug in for the correct variable. 3 is greater than 3 times -1 minus 4. 3 is greater than, this is -7. That's a true statement. And I'm not going to show you the other two, but you get the idea. It would take too long. All right, how do you know whether the boundary line is part of the solution? A solid line is part of the solution. A dashed line is not. A dashed line, okay, because every point on the line equals. Okay, so for a solid line, we have greater than, equal to, less than, equal to. For a dashed one, we have greater than, less than. So everything on the line is equal to. So the only way that it would be part of the solution is if we had the equal to inequalities. These two do not have equal to with them. Okay, and I plotted every one of these points, and you can see which ones work. So 5, -5 is on a dashed line, so therefore it doesn't work. 3, 5 is on a solid line. It does work. And look, you're looking at the double shaded region, which is this region over here. 2, -1 right here. I didn't do that one. Oh, I did too. -2, 1. I read it backwards. -2, 1 is right there. It's just in the double shaded region. It works. 6, 2 is right there. Is right in the shaded region, and 6, -8 is not in the shaded region. And the 0.35, if I failed to mention it earlier, is on the solid line, and it works. A toy, I thought it's around Christmas time I liked this question. I made it up. All right, so $10 on every truck and $5 on every bear, and they want at least a profit of at least, that's greater than or equal to $500. You know they want to make all the money they can. Given the inequality, is the point part of the solution? No, it's not. It's on a dashed line. If you put this into Desmos, it would be sitting on the dashed line. But you just literally plug it in. 57 less than 3 times 12 plus 21. And you'll get 57 less than 57. And 57 is not less than 57, it equals. All the points on the line equal. and there's no equal to there, so it's not part of the solution. The sum of two rational numbers is rational. The sum of two irrational numbers will be irrational. The sum of a rational and an irrational number is irrational. All right, this is irrational. Where pi is concerned, pi is going to always be irrational. You can put it in your calculator and take a look at it. If it fills the calculator screen up without showing any kind of pattern, then it doesn't work. So you do 3 times pi is right here. On the x10x, you hit shift, hit that, hit equals. Now, hit your SD button. See how it fills the screen up, and there's no pattern. That's irrational. 7/9, if you put it in your calculator, and you hit equals, you're going to get 7/9. However, and see the bar? That means it repeats. That's rational. Plus, the very definition of rational is that it can be written as a ratio of two numbers, which is a fraction. So there we are. That's a fraction. It's rational. The square root of 5, y'all, a radical, leftover radical is going to always be irrational. So if I put square root 5 in the calculator and hit equals, it gives me that. And then if I hit the SD button, see how it fills it up, and there's no pattern. Okay, 3/5 fraction, rational. This is 12. If you put it in your calculator and evaluate it, that'll be it. It's rational. All right, put that in your calculator. Remember, you just put it in it, hit equals, you get 6 square roots of 2. Same thing, this goes in the calculator. All right, this won't go in the calculator. Remember to do your factoring tree. And it takes 3 of the same number to bring it out. We're bringing out a 3. We have a negative there, so we pull in negative. So -3 cube roots of 2. All right, now, I want you to hear me and hear me well, because there's no reason to miss these. I gave you a graphic organizer. It's on Google Classroom as well, that explains how to use your calculator and what all that stuff on the calculator means. If you plug this into Mode 5.3, you will put your A as -4, your B is 36, and there is no C term. So you say C is 0. You put 0 in. Mode 5.3, the very first two things you see are x1 and x2. That's the solutions. I don't want that here. We're talking about maximum height. That means we're talking about the vertex. So the third and fourth things that pop up on Mode 5.3 are your x and y coordinate of your vertex. It'll say x coordinate of maximum value, and then the next one says y coordinate of maximum value. So that's 4.5. That's the time that it takes for the soccer ball. When we do our thing, the time it takes for a soccer ball to be right here, that's at 4.5, okay? And the maximum height is 81 feet. That's going to be the y coordinate. Now look and read that graphic organizer I gave you. This is the same problem. How long was the soccer ball in the air? Well, it was in the air for 9 seconds. This is where it started. Your x1 and x2 are 0 and 9, and I don't know which one it puts first in the calculator, but it puts them both there. So the ball, the soccer ball, was in the air for 9 seconds. The T represents time. That's your x. Okay, what is the height from which it was kicked? That's the starting point right here. That's its y-intercept. That's going to be that one. And so that's 0. And plus, you've got plus 0 here. Okay. All right, and then it says determine the domain and the range. Well, here's our sketch. And if you need to, put it in Desmos and look at it. It will graph this in Desmos. So the domain is going all the way from 0 to 9. And the range is going from 0 to 81 feet. That's your height. This is your maximum. That's all your x values. So from 0 to 9. And then all your y values go from 0 to 81. All right. This is a problem that you will see too as well. This is a real world problem. And this is wanting to know what the domain is. Well, y'all, the domain is your x values. So this is going from 0 to 8. That's as far as it goes. Same exact thing. What's the y values? Well, remember we always put the small number first, so the depth here, it's going from -16 up to 0. The diver comes up out of the water. They don't rise up above because, you know, men can't fly. We don't have wings. So from -16 to 0. Interval of increase, same thing. This is our rock that we're pushing up. So we're increasing from 4 to 8. And we are, same problem, we are decreasing from 0 to 4. That's when he's diving, he or she. And then this is when they're going back up. Vertex, 4, -16. Axis of symmetry, that's a line. That is x equals 4. You don't write the whole vertex down for the axis of symmetry. It's just the x coordinate. Okay, same thing on this. The vertex is at 4, -1. This just isn't real world. It's just some random graph. And the axis of symmetry is here at x equals 4. X-intercept, y-intercept, sorry. You can't see it. This graph is going to have one. I didn't pick a good graph here. This graph is going to have one way off up there somewhere, but we don't know what it is. So we'll not worry about it, but whatever it would be, it's where it crosses the y-axis. The x-intercepts are at 3, 0 and 5, 0. And your roots, now the reason I put it this way, I call them zeros. Another teacher called them roots. I want you to know they're the same thing. It's the x-coordinate of the x-intercepts. So that would be 3 and 5. Same problem? Oh, no, it's not. Okay. This is a multiple choice where you have to look and find out, have they put it into the quadratic formula properly? Well, this is your b, so -b plus or minus square root of b squared. So if I square the 5, I get 25 minus 4 times the a, which is 1, times the c, which is -14, all over 2a. This is what you'd be looking for, and it's a multiple choice question on the test. Just be sure you know what the quadratic formula looks like. The quadratic formula is provided for you on that question. All right, this says find the solutions of. Y'all, I put mode 5.3 in. This is mode 5.3. Mode 5.3 will spit out an x1 and an x2. Don't change the signs. Mode 5.3 actually does give you these solutions, not the factors. Now, if you do it by hand and do it with your head, you factor it. You put -14 here and 5 here. The two factors of 14 that subtract to be 5 are 7 and 2, and the 2 is negative. Notice, that's the factors. Factors are opposite of solutions. That's what I keep saying. So here's the factors. The factors are this. But the solution's actually the opposite signs, because what makes this be 0? -7 plus 7. What makes this be 0? 2 minus 2. So solutions is what mode 5.3 gives you, and you don't have to change anything. Okay, the y-intercept. If you multiply this on out using FOIL, you'll get -15 on the end, and that's it. You can put that into Desmos, just like it is. Just looking like that, and you'll be able to see where the graph crosses the y-axis at. I'm thinking, no, different problem. But anyway, that's how you do it. The quadratic equation, the graph of a quadratic equation is called a parabola. Write an equation in factored form. This is factored form. I actually did it the way I taught you. I put 12 here, 8 here. What factors of 12 add to be 8? 6 and 2. So that's that. Or if you go into mode 5.3 and you put it in mode 5.3, x1 and x2 is going to be -6 and -2. And here's where you change it to find the factors. Write an equation that matches that in vertex form. If you were to multiply this on out and get it in and put it in, actually this is, if you multiply it on out and you put it into your calculator is going to give you an x coordinate on that third answer. is going to give you the x-coordinate of the maximum, which is negative 1.5. And the fourth answer is going to be the y-coordinate of the maximum, which is 20.25. Remember, you have to change this one to write the equation in vertex form. So I have that minus sign there. I put it here, and I go x plus 1.5 squared, and then I just put the maximum over there, plus 20.25. If you want to put it into Desmos, and I think I have it there, x minus 3, x plus 6, I do. You can use Desmos to find it. There's the vertex right there. And then just remember to change that sign to change the sign of the negative 1.5. That's just how it works. Okay. All right, the zeros of the equation, y'all, simplest thing to do, mod 5-3 when it asks for zeros. Mod 5-3 is x1 and x2 or that. Same thing on this one. The easiest thing to do is mod 5-3. Thank you.